Hello, good morning to all. I am Monica Yamul and today I am presenting a topic on routing and routing algorithms. Introduction to routing. Routing is a fundamental concept in a CN that involves selecting a paths for data to travel from source to destination across a interconnected network. It ensures that data packets are delivered accurately and efficiently even across complex and large scale network structures like internet. Its specialized network devices, casual routers make uh, routing decisions using routing tables to determine the optimal path. There are a key concept of routing. Purpose of the routing determines how data travels from one device to another through intermediate device like routers, routers and routing table. Next is the importance of routing. It ensures efficient data delivery across multiple network and it supports scalability in large networks like ISPs or enterprise environments, and it is also helps optimize the network traffic, reduce delays and avoid congestion or loops. There are two, two primary types of routing. First is a static and the second is a dynamic routing. A static routing, it uses manually configured unchanging routers. Means in this static routing, administrator when change the routers, that time user can change the routers. Next is a dynamic routing. In that dynamic routing, it automatically adjusts routers based on current network conditions or improving adaptability and efficiency. Uh, Next is the routing algorithms. In that, mainly two algorithms are present. First is a distance vector routing and second is a length state routing. These algorithms are used to select the shortest path for travel source to destination. First is a distance vector algorithm. The distance vector algorithm is a routing protocol used in a computer network to find the shortest path for data packets between nodes or routers. Its work is each router keeps a table which is called a distance vector and the distance or a cost to reach every other routers and the next op to use to get three routers. The routers share their distance vector with directly connected neighbors. Means in that example there are four routers A, B, C, D. Uh, their A neighbor router is a B and D and a C. And routers share their distance vector with directly connected routers and each router updates its table based on information from neighbor aiming to minimizing the cost, and this process continues until all routers have an optimal path. The distance vector algorithm, based on one example which I take, in that example four routers are present A, B, C, D. Firstly we take all routers separately take one destination, means routing table. A to B, A to C or A to D, we find a distance and a next to. In that example, first A to A routing table means destination A, B, C, D and distance A to B. A to A distance is 0 and the next to OP is A, and A to B distance is a 12 and the next OP is a B, and A to C distance is a 9 and next OP is a C, and A to D is a distance is 4 and next OP is D. Same like as all routers we take a routing table, and next is we take a A's distance means A's routing table in that distance, and B routing table of distance and C routing table, and from D routing table we take a distance from A to D, A to C, A to B, or A to B. Next is the router A to B's distance with the new distance is shown below. Means we the new updated routing table at A is created. Firstly, we take A to B routing table. In that, we take firstly means A to B means A to B. A's neighbor nodes we take means their neighbor nodes are A to B, A to C, and A to D. So we can find the A to B value is a 12 and B to B is a 0. Means 12 plus 0 is 12, and next neighbor node is A to C. So A to C is distance is 9 and C to B is distance is 1 plus, so 9 plus 1 is 10, and next neighbor node is A to D plus D to B. A to D is a 4 and D to B is a infinite, so final answer is infinite. So this is the new values are put in the distance new updated routing table. And second is the router A to C's distance with new distance. It is the same like as firstly we create A to B, so it is A to C means A to C. There we find two neighbor nodes of A to C. Means there are the neighbor nodes are A to B, A to C, and A to D. So same like as we find their distance and we put their new distance in the new routing updated table. It is the process of the distance vector routing algorithm. And next is the link state algorithm. The link state algorithm routing is a type of routing protocol used in packet switched network where routers share information about the state of their links, means connections, and it to build a complete map of the network topology. In that link state routing, each router then independently calculates the shortest path to every other routers, means it path to every other router, and the router monitor the stack of their links and advertise the information. And link state routing is a type of routing protocol in that above the state of their links or connections. Next is the challenges in routing. In the challenges, some challenges of routing algorithm. First is in computer network. First is a scalability challenge, means managing a routing tables and maintaining a performance as the network grows. And second is a dynamic topologies. Adapting to change in a network structure due to mobile device and a network failure. The security vulnerability can also arise, necessitating secure routing protocols to protect data. And effective routing requires continuous monitoring and adaptation to changing network conditions. And last is the future trends in routing. The future trends in routing with a focus on a software defined networking SDNs means software defining and the integration of AI and machine learning into routing. SDNs means software defined networking is a revolution in how routing is managed and implemented by separately the control plane from the data plane, or enabling centralized network control. And this is the overall information about the routing and the routing algorithm. Thank you.